Hello guys. So in that operation research, successfully completed 3 technique videos. So hope everybody are understand. Now today, so I'm going to start the another technique of OR, that is linear programming problem. So note that this is fixed question. Everybody knows section C, the second main, the last question. So maybe 35th question, 35th of section C. So definitely that is linear programming problem. So that is called LPP. So let me start question number 1. So question is like this. Solve LPP by graphically. Please take down. Solve LPP by graphically. Yeah, question is ready. So maximize Z is equal to 10x plus 15y. So equation number 1. Maximize Z is equal to 10x plus 15y. Similarly, subject to constraints 3x plus 2y lesser than or equal to 18, 4x plus 3y greater than or equal to 12. So that is equation number 2. And finally, equation number 3, x comma y greater than or equal to 0. So that is non-negative restrictions. I know that before going to start here, so we should remember when there is a lesser than or equal to is there from equation number 2, this one. From equation number 2, lesser than or equal to, you feel it, that is inside the horizon. So inside the horizon. So whether from 2 equation, the constraints are lesser than or equal to, is nothing but inside the horizon. So how it is, how to mark inside the horizon? Yes, there is a line here. Okay. Fine. So inside the horizon, so this way, this is horizon here. So this is x-axis, this is y-axis. So this is inside the horizon. So this way you have to shade it. Okay, this is the lesser than or equal to from 2. So that is inside the horizon. Similarly, greater than or equal to, so that is called outside the horizon. That is called outside the horizon. For example, suppose there is a axis is like this. Okay. So we are going to mark outside the, from this line, outside the horizon, from this line. So this way. Okay. So this is called greater than or equal to. From 2, lesser than or equal to means inside the horizon. So greater than or equal to means outside the horizon. That's very important. Every LPP, you should aware of this one. Lesser than or equal to inside the horizon, greater than or equal to outside the horizon. So yes, the solution. So for LPP, linear programming problem, we are going to start from 2. From 2, 3x plus 2y lesser than or equal to 18 becomes, so 3x plus 2y is equal to 18. Similarly, 4x plus 3y greater than or equal to 12 becomes 4x plus 3y is equal to 12. So this is method number 1 in LPP. Treat inequality as equality. So 3x plus 2y lesser than or equal to 18 becomes 3x plus 2y is equal to 18. Similarly, 4x plus 3y greater than or equal to 12, this is inequality, becomes equality. 4x plus 3y is equal to 12. Okay, next. So we are going to prepare a small table. So when we are going to draw the graph, so we need some 2 point. One is called x point and y point. Put y is equal to 0, put x equal to 0, and finally we'll get axis there. Okay, so this is y is equal to 0, x is equal to 0, and x comma y. That means the first one. So 3x plus 2y is equal to 18. In this equation, put y is equal to 0. So 3x plus 2 into 0 is equal to 18. The finally, 3x is equal to 18. So x is equal to 18 by 3. So x is equal to 6. So x is equal to 6. Similarly, same equation, put x equal to 0. 0 plus 2y is equal to 18. Therefore, 2y is equal to 18. So y is equal to 18 divided by 2. So y is equal to 9. So finally, x point is 6 and y point is 9. So next, 4x plus 3y is equal to 12. Please put y is equal to 0. Therefore, 4x plus 0 is equal to 12. Therefore, 4x is equal to 12. So x is equal to 12 by 4. Therefore, x is equal to 3. X equal to 3. Similarly, put y is equal to 0. Put x equal to 0. 0 plus 3y is equal to 12. So 3y is equal to 12. So y is equal to 12 by 3. So y is equal to 4. Y is equal to 4. Finally, we got 3 comma 4. Finally, we got 3 comma 4. This is 6 and this is 9. So 6 comma 9 first equation, and the second one 3 comma 4 second one. So this is the second method. So 6 comma 9 and 3 comma 4. Okay. The first one, inequality as equality. And the second one, we are going to draw the graph. So when we draw the graph, we need per equation 2 points, that is x comma y, and second equation x comma y. The first equation we got it. So that is 6 comma 9. And the second one, so 3 comma 4. So let me check. Look at that x-axis, 6 comma 9, y-axis is 9. So which is the highest one here? So x-axis highest is 6 and y-axis highest is 9. So based on that, we are going to draw the graph. So let me see now. So if I take scale pencil, if graph sheets is there, okay, better. Fine. Okay. So let me start. So x-axis, then y-axis. Look at the x-axis highest is 6 on. So we are going to start. So 1, 2, 3, 4, 5, 6. Okay. So y-axis highest is 9. There is a 9, 4 is the highest is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The first equation point is 6, 9. Yes, very good. 6 comma 9. 6 is x-axis, 9 is y-axis. Okay. Now we are going to join these two lines this way. Okay. Now, after that, after first line, we are going to draw we are going to draw whether it may be inside the horizon or outside the horizon. Look at that. There is a lesser than or equal to is that first line. So that is lesser than or equal to means what? Inside the horizon. Just look at that this way. So when there is a small line, one big one, you have to put arrow mark. So inside the horizon. Yes, this way. So inside the horizon. Fine. Now we go for second one. So 3 comma 4. This is 3 and this is 4. So 3 comma 4. Let me join this one. Yeah, 3 comma 4. Okay. So this one is greater than or equal to that. Look at that here. Greater than or equal to. Greater than or equal to nothing but outside the horizon. Yes. From this line outside to this way. So outside the horizon. Yes. Now look at that, guys. I used two color. One is red and one is blue color. Both the colors are coincide. So both the colors are coincide only for this area. So look at that. Yeah, this is the area. So blue color and red colors are coincide. So this is called feasible. This is called feasible region. Yes. So this is called feasible region. Okay. So after marking inside the origin and outside the origin, we got feasible region and we have a 4 corner point. Yes, we have a 4 corner point. The one corner point is A and this is the B and this is C and this is D. We have a 4 corner points are there. Okay. The first A corner point, look at that. A touches is only y-axis so that we are able to write 0, comma 4. So 0, comma 4. 0, comma 4. So B corner point, it touches only y-axis. So that is 0, comma 9. Okay. 0, comma 9. Similarly, C corner point, it touches only x-axis. That is 6, comma 0. And D corner point, it touches only x-axis. So that 3, comma 0. So that 3, comma 0. So after identifying 4 corner point, we are able to find the optimal solution. We are able to find the optimal solution. So let me see how it is optimal solution. Okay. So I'm going to mark here optimal solution. Fine. So there is a, we are able to write maximize z is equal to 10x plus 15y. Then okay, we'll change the table format. So that is okay for that. Now there is a corner point. Okay, then maximize z is equal to maximize z is equal to 10x plus 15y from 1. Okay, first corner point. So 0, comma 4. So now let me check what is the answer. So put x is equal to 0 plus and y is equal to 4. So 15 into 4. So 60. Similarly, B corner point. So 0, comma 9. So 0, comma 9. Maximum z is equal to 10 open bracket 0 plus 15 open bracket 9. So 135. 135. C corner point 6, comma 0. So maximize z is equal to 10 open bracket 6 plus a 15 open bracket 0. So 10 into 6 is 60. Okay, similarly, D corner point 3, comma 0. Okay, so maximize z is equal to 10 into 3 plus 15 into 0, 30. Yes, they're asking maximize. Look at the last table, which is the maximize answer. So maximize answer is 135. Look at that. Maximum answer is 135. Guys, correct answer, huh? So maximum answer is 135. Therefore, finally, so my comment should be there. So maximize z is equal to 135 when x is equal to 0, this one, and y is equal to 9. X is equal to 0, y is equal to 9. So this is the first question answer. So this is linear programming problem. So we'll move on to second one. Second problem. So let me start. Okay. Guys, I need clarification whether the answer is right or wrong. Okay. The second one. Solve LPP by graphically. Solve LPP by graphically. Right equation. Maximize z is equal to maximize z is equal to 6x plus 10y subject to constraints x plus y lesser than or equal to 8. X plus y lesser than or equal to 8 and x plus 3y lesser than or equal to 18. Finally, x comma y greater than or equal to 0. So mark it equation number 1 and equation number 2. Equation number 1 and equation number 2. So this is equation number 1, equation number 2, equation number 3. Okay. So let me start from 2. From 2, x plus y lesser than or equal to 8 becomes x plus y is equal to 8. X plus y lesser than or equal to 18 becomes 18 becomes so 3y. 3y, x plus 3y lesser than or equal to 8 becomes, so x plus 3y is equal to 18. Now after that, so y is equal to 0, x equal to 0, finally x comma y point. That's the first one. X plus y is equal to 18. So y is equal to 0, x plus 0 is equal to this is 8, x plus 0 is equal to 8, finally x is equal to 8. Put x is equal to 0, so 0 plus y is equal to 8, therefore y is equal to 8. Finally x comma y point, so 8 comma 8. So 8 comma 8. Similarly for the second one, so x plus 3y is equal to 18. But y is equal to 0. X plus 3 into 0 is equal to 18. Therefore, x is equal to 18. Similarly, put x equal to 0. So 0 plus 3y is equal to 18. So x 3y is equal to 18. So x is equal to 18 by 3. So x is equal to 6. So this is 18 comma 6. 18 comma 6. Okay, 18 comma 6. The first point 8 comma 8. Second one 18 comma 6. So after this, now we are going to solve. We are going to draw the graph. So we required x-axis and y-axis. Okay, so y-axis and x-axis. So let me start. X-axis is 8 comma 8 and 18 comma 6. So x-axis highest is 18. So better to start 2, 2. 2, 4, 6, 8, 10, 12, 14, 16, 18. So x-axis 1 centimeter is equal to 2 units. The second one, y-axis highest is 8. So 1, 2, 3, 4, 5, 6. Okay. Let me draw the line. First one, 8 comma 8. 7 and 8. Okay. So 8 comma 8. Fine. That is 8 comma 8. Okay. Now look at the from 2 is the lesser than or equal to. It means what? Inside the horizon. So inside the horizon. You have to mark like this. Okay. Second one. 18 comma 6. So 18 comma 6. Okay. 18 comma 6. Yeah. Look at this here. So 18 comma 6. Fine. So that is also lesser than or equal to. Means so inside the horizon. Inside the horizon. Yes. So inside the horizon. Okay. Inside the horizon. Now, green color and red colors are coincide this area. So you also in the examination, two color you can use it. One is pen, one is pencil. So this area is called feasible. It's called feasible region. Yes, you have to mark it. So and write feasible region. How many corner points are there? Yes, we have a 4 corner point. So look at that. This is A and this is B. And there is a two lines are existence here. So that is called C and this is called D. Okay, the first A corner point, so that is 0, 0. And B corner point, it touches only y-axis, that is called 0, 6. So let me see the first one. So that is the points are coincide here. We are able to identify. So 1, 1, 2, 8. Okay. Second one, 1, 3, 18. Yes, no. Yes, no. So anybody got this answer? Because those who are using graph sheet, so this point is very easy to identify. So that is called C. And D point, so 8, 0. So let us start. 1, 2, 3, and equation is 1. Okay. So 2, 1, again 1, then 8. Okay. 1 is equal to 3 is equal to 18. The first is 3 x-axis. The next is 5. Yes, I got 3, 5. Okay. 4 corner point we got it. A corner point is 0, 0. B corner point is 0, 6. And C corner point is 3, 5. And D corner point is 8, 0. Now corner point. Now corner point. And the first one, maximize z is equal to 6x plus 10y. 6x plus 10y. So the first corner point A, 0, 0. So definitely maximize z is 0 because for x equal to 0, y is equal to 0. So B corner point 0, 6. Therefore maximize z is equal to 6 open bracket 0 plus 10 open bracket 6. The answer is 60. C corner point 3, 5. So maximize z is equal to 6 open bracket 3 plus 10 open bracket 5. 10 open bracket 5. So what is the answer? So 6 open bracket 3 plus 10 open bracket 5. 3, 5. Answer is 68. The last one, D corner point 8, 0. So maximize Z is equal to 6 open bracket 8. 6 open bracket 8, Y open bracket 0. So finally answer is 68. They ask maximize. So what is the maximize answer? So 68 is the maximum answer. So that is, so maximize Z is equal to 68 when X is equal to 3, then Y is equal to 5. So this is the second part. X is equal to 3, Y is equal to 5. The second problem for linear programming problem. Now we'll move on to third question. So let me see. Okay. Solve LPP by graphically. So maximize Z is equal to 50x plus 60y, subject to constraints 5x plus 4y lesser than or equal to 40, and 3x plus 4y greater than or equal to 24. Finally, x comma y greater than or equal to 0. So step number 1, 5x plus 4y lesser than or equal to 40 becomes 5x plus 4y is equal to 40. Similarly, 3x plus 4y, so greater than or equal to 24 becomes 3x plus 4y, so is equal to 24. So it's equal to 24. Now, step number 2, to draw the graph, find the first one, 5x plus 4y is equal to 40. Put y is equal to 0. So 5x plus 0 is equal to 40. Therefore, 5x is equal to 40. X is equal to 40 divided by 5. So x is equal to 8. 8 5s are 40. Okay, similarly, x is equal to 0. So 0 plus 4 5 is equal to 40. So 4 5 is equal to 40. Therefore, y is equal to 40 divided by 4. So y is equal to 10. So 8 comma 10. So this is x comma y point. Similarly, 3x plus 4y is equal to 24. But y is equal to 0. So 3x is equal to 24. Therefore, x is equal to 24 by 3. So finally, 3 8s are 24. Therefore, x is equal to 8. X is equal to 8. Similarly, y is equal to x equal to 0. 0 plus 4y is equal to 24. 4y is equal to 24. Therefore, y is equal to 24 by 4. What is the answer? 6. So that is 8 comma 6. So 8 comma 6 and 8 comma 10. Okay. Now we can go through step number 2. So that is draw the graph. So y-axis, x-axis. X-axis highest is 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So x-axis 1, 2, highest is 10, 3, 4, 5, 6, 7, 8, 9, 10. Let me start first one. So 8 comma 10. So 8 is here, 10 is here, 8 comma 10. So that is lesser than or equal to. So lesser than or equal to means inside the origin. Okay, inside the origin. Second one, 8 comma 6. So 8 comma 6. Okay, 8 comma 6. That is greater than or equal to. Look at that, greater than or equal to. It means outside the origin. Yes. So look at that, both the colors are coincide. So one area. So that is called feasible solution. So this area is called feasible solution. We mark it as A, then B, then C. A, B, C. Okay. A corner point 0,6, B corner point 0,10, and C corner point 8,0. Okay, now corner point and then maximize Z is equal to 50x plus 60y. So A corner point 0,6. So maximize Z is equal to 360 and B corner point 0,10. So maximize Z is equal to 600 and C corner point and C corner point, so 8,0. Therefore, maximize Z is equal to corner point. So corner point maximize Z is equal to 50x plus 60y. Okay. The first corner point A 0,6. 0,6. So B corner point 0,10. C corner point to 8,0. Okay. So maximize Z is equal to 50 open bracket 0 plus 60 open bracket 6. So answer is 360. So maximize Z is equal to 50 open bracket 0 plus 60 open bracket 10
empty ನನಗ್ಬೇಕು
is equal to 600. So maximize Z is equal to 50 open bracket 8 plus 60 open bracket 0, so 400. So here highest, because they ask maximize here. So maximize is nothing but 600 is the answer. So finally, so maximize Z is equal to 600. So when x is equal to 0 and y is equal to 10. X equal to 0, y is equal to 10. Okay, we'll see you tomorrow.